and I put it here in Notability, and I went through and I worked out each one. So now I'm going to explain the answers. You guys have to write this down and turn it in so that I know that you did it. I have no way of knowing if you're watching these videos unless you turn something in. So that's why I'm requiring this. You have the entire week to do it. So take your time. Don't think you have to do all of it in one day. But I do want you to do it. You have to have it done by Friday, and because your test has to be also done by Friday. So makes sense to do the review before you do the test. So that being said, number 1 says to determine whether the set of data displays exponential behavior and explain why or why not. So I looked at my values of x, and then I looked at my values of y, and x is adding each time. We're increasing by 1, and y is also adding 3 each time. So it's increasing by 3. Therefore, we know that it's linear and not exponential. Number 2, if we look at it, x is increasing by 5, and each time y is going down by, I'm dividing by 2, which is the same as multiplying by a half. So because of the multiplication piece, we're not adding or subtracting each time, we're multiplying by a half. That tells me that yes, it is exponential. Number 3, as x increases by 4, y is going up by multiples of 2. Once again, it's multiples, therefore it is exponential. Number 4, x is increasing by 20, or it's decreasing by 20 each time, and y also is decreasing by 20 each time. We're subtracting, we're not multiplying or dividing, therefore it's linear and not exponential. So number 5, I'm not going to go into a lot of detail because I've already did this problem in a previous video, but I will walk you through it just in case you didn't watch that one. We have our 2 points, and we know that we're trying to write an exponential function, y equals a times b raised to the x. So what I did was I took these points, 2, 16, and I plugged them in, the 2 in place of the x, the 16 in place of the y. And I did the same with the 332. Plugged in the 3 in place of x, 32 in place of y, and then I solved the first equation for b, and I did that. Oh, my children, they drive me nuts. I just can't even make a video. Oh, I told them what I was doing and everything. Knocking on the door, making the dog bark. So anyway, divided both sides by a to get b by itself, take the square root of b. Now I have that b is equal to this whole thing. So I took this and I plugged it in place of b, and b is equal to 4 over the square root of a. Then I cubed all of that, and that's where this came from. Simplified, I did all the math. Once again, I explained that in the video. So now I figured out that a is equal to 4. So I take that 4, plug it in for a. I'm still using this 0.2 and 16 up here. Plugged it in, I solve for b. Divide both sides by 4, I get 4 equals b squared. So I take the square root of each side, and I get b equals 2. So I plug in my a and my b, and I have y equals 4 times 2 raised to the x. And I know I'm going through this really fast, but you can pause it at any time that you want or go forward or backward. You don't have to go as fast as I'm going. Pause your video. Take your time. Make sure you're understanding this for your test. So then I have the points 290 and 4,810. I did the same thing as I did in number 5. I plugged in the 90 for my y, the 2 for my x, and I solved for b. I got b equals the square root of 90 over the square root of a. I took that value and I plugged it into the other equation in place of b. So I used these points now for my y and my x and plugged in that value for b. And then I solved for a. So the square root of 90 raised to the 4th power, remember 90 is the same as, the square root of 90 is the same as 90 to the 1/2. And when I have a power raised to a power, I multiply those exponents. So half of 4 is 2. So really I just have 90 squared. The bottom is the square root of a. When I take that to the 4th power, that's 1/2 times 4, which is 4/2 or 2. So I just end up with a squared in the denominator. So then I simplified. A over a squared is nothing more than a in the denominator. There's more in the denominator than in the numerator, so I had to leave it there. So then I times both sides by a, getting 81,000, that's 90 squared, or 8,100, I'm sorry, equals 810 times A. So I divide both sides by 810, and I get A is equal to 10. Oops. Okay, so then I take that value and I plug it in for A, and I solve for B. So I have 90 equals 10 times B squared. So I divide both sides by 10, and 90 divided by 10 is 9. So I have 9 equals B squared. I took the square root of both sides and got B equals 3. So then I just plugged it in, and Y equals 10 times 3 raised to the X. And then number 7 is much the same way, only it's actually a little bit easier because this time it gave us the coordinate 1. Anything to the first power is just 1. B to the first is 1. 1 times A I know is A. So I just am able to simplify here. Or I'm sorry, I said anything to the first power is 1. That is a lie. Anything to the 0 power is 1. B to the first is just B. Sorry. So anyway, I'm really distracted by my kids talking so loud, even though I told them that I was coming in here to make a video. They just don't care. So back to my problem here. 12 equals A times B raised to the first. I divide both sides by A to get B by itself. So I have 12 equals B to the first. 12 over A equals B to the first right here. And I take that value and I substitute it into this other equation in place of the B value. So I'm just taking the B out, and in its place I'm putting what B is the same as. B is the same as 12 over A. So now I have all of that raised to the third power. So I cube 12 and I get 1,728. I cube the A and I get A cubed. And then I still have this A, which is in the numerator. So I have A over A cubed, which simplifies to A squared. And you would think A squared in the numerator, but let's look at where there's more. There's 1 A on top. There's 3 A's on the bottom. So 1 on top cancels with 1 on the bottom, leaving me the 2 on the bottom. So I can't have that A squared down in the bottom. So that's why I times both sides by A squared, was to get that out of there so that I can later solve for it. So times both sides by A squared, boom, that's gone. So now I have 192 times A squared equals 1,728. I divide both sides by that 192. So I'm left with A squared equals 1,728 divided by 192 is 9. But I don't want A squared, I want just A. So I take the square root of both sides, and the square root of 9 we know is 3. So now I can take this and I just plug it back into this equation over here where I solve for B. 12 divided by A is B. Well, I know that A is 3. So 12 divided by 3 is B. Therefore, B is 4. And I have the answer, Y equals 3 times 4 raised to the X power. Number 8 is the one that I was thinking ahead to. It's the super easy one. We automatically know A. A is 0, 3. That's this point right here. So then I looked for another point, and it looks like -1 passes through about halfway between 1 and 2. So I have -1, 1.5, and I don't even have to solve like we did up here. I have 2 points, and I could do it like I did in number 7, but I don't have to because I automatically know that A is 3 if I have the 0. If I know that X is 0, then Y has to be 3. So that means that A is 3, so I plug that in. So I plug in my 3 for A, plug in my -1 for my X, I plug in my 1.5 for Y, and then I solve. So I have B to the negative first. I don't want B to the negative first. So what I did here was I just multiplied both sides by a B, because I know that if I have B to the -1 times B, a -1 plus 1 is 0, so that just leaves me with 1, so boom, those are canceled. So I have 1.5B equals 3. I divided both sides by 1.5, and B was 2. So I plugged in my B, 2. I plugged in my A, 3, and I get Y equals 3 times 2 raised to the X. Okay, number 9, much the same way. I looked at the graph. I figured out some points that were on it. Luckily, I already knew the y-intercept, so that gives me the A value. Your y-intercept is your A value. That's your initial amount, your starting point. So start at -1. I plug in 3 for y, plug in 1 for x, and I solve. Divide both sides by -1, and I get b equals 3. So then I have y equals -1 times 3 raised to the x. So that takes care of page 1 of your review. If you want to stop your video here, pick up tomorrow. That makes sense to me, so you're not overwhelmed doing it all in one day. Okay, number 2, or page number 2. We're starting with number 10, and it just wants us to describe the transformation that took place. So looking at this, I can see that the only thing that changed in the equation was we added 8 to the parent function. So if I add 8 to the whole thing, that tells me that the function just shifted vertically 8 units. Number 11, the only thing that changed was this exponent went from just a 1x to a 1/2 x. So since that value is less than 1 and it's part of the power, then I know that I'm stretching it horizontally away from the y-axis. That's what I have written here. Okay, so number 12, because of the negative, that tells me that it's a reflection across the x-axis. And because we multiplied the entire function by 3, that tells me that I'm stretching it vertically. Okay, then number 14, you just had to graph them. And 15, I would go to Desmos if it were me, but I just picked some values and plugged them in and then tried to graph them as best as I could. Little hint, I might have you tell me which graph on your test matches a function, but it's going to be on Google Forms, so I'm not going to ask you to actually graph it yourself. You'll just have to be able to recognize the graph of a function. Okay, so back to this. Number 16, we're finding the 10th term if the sequence is geometric. So first thing I have to decide is if it's geometric or not. And what I did was I looked at what's happening to get from the one number to the next. Well, I can see that I times by 5 each time. So since it's multiplying, that tells me, yes, it is geometric. Then I just plug them into the formula. This a sub 1 is the first term. My first term is 4. R is my rate. My rate is 5. And then n to the n minus 1, well, n just represents our term that we're looking for. Well, in the directions it said to find the 10th term. So I did 10 minus 1, which is 9. And then I simplified. 5 to the 9th is this big old number. Times it by 4, and I get this big old number, which happens to be 7,812,500. Did the same for number 17. I can see that each time we're dividing by 2. Dividing by 2 is the same as multiplying by a half. So my rate is 1/2. Plugged in my first term of my sequence, my a sub 1 is 212. My rate is 1/2. I'm looking for the 10th term. And I got 53 over 128. There's a cool little feature on Desmos where you can just click and it converts your decimal into a fraction. And then number 18 and number 19 are not geometric. So once again, I would stop the video here and I would pick back up here tomorrow. We're just going to finish up with 20, 21, 22, and 23. I worked them out here. Number 20, it says, find the first 5 terms of each sequence. Well, it gives us the very first one, so really we only have to find 4. So we've got 23 as our first one. So then we plug that in here. 23 plus 7 is 30. Then I plug the 30 in here. 30 plus 7 is 37. 37 plus 7 is 44. 44 plus 7 is 51. So that's how we did this one. Number 21 is a little bit more involved. But we know the first term is 13. So then I just plug it in. -2 times 13, take away 3 is -29. Plug in my -29. -2 times -29 gives me a positive number. Then I subtract 3 and I get 55. And you might want to double check my math because I did these really quickly. But anyway, don't take my word for it. Check me. I plug in the 55. -2 times 55 would be -110. -110 minus 3 is -113. Then I plug in the 223. I'm going to pause right here because I told you guys I was going to give you hints for the word of the week. So this week's word of the week describes me. It describes me to a T. It's a 4-letter word, and I know what some of you are probably thinking, but it's not a bad word. I don't use bad words, and I don't think about any bad words out there describe me. So it is a 4-letter word that describes me. That's your hint for today. Okay, enough of that commercial break. Let's go back to the lesson here. Number 22 is where we are. We are going to write a recursive formula. So we know the a sub 1 is 12. It told us that. So I write that down. Then I look for a pattern. What do I do to get from the first number to the next number? Well, looks like to get from 12 to 1, I subtracted 13. Let's see if that pattern continues. From -1 to -14, I subtract 13. From here to here, I subtract 13. So I take the previous term. We have a to the n minus 1. That just means the previous term. And I subtract 13. And this has to be for all values of n greater than 2. Okay, so now going on to the next one. We're looking for 23. We're looking for the recursive formula. Our first term is 27. So that's my a sub 1. Look what we do to get from 27 to 41. It looks like I add 3, add 10, add 1 more. So I add 14, add 14, add 14. The pattern continues. So I know that I take the previous term and I add 14, and I say for all values of n greater than or equal to 2. And that takes care of your review. Make sure that you understand this. You can watch these videos as many times as you want, but that takes care of your review for the week.